So today I'm going to explain the periodic trend of atomic radius on the periodic table. So the basic trend is that atoms get larger as you go from top to bottom and larger as you go from the right side of the periodic table to the left side of the periodic table. So I'll start first with why does it get bigger as you go down? And this all has to do with increasing the number of consecutive orbitals that are wrapped around the middle of the atom. So the middle of the atom is the nucleus, and in the first period, you just have one ring you can think of around the middle of the nucleus. This ring holds electrons, and that's called an orbital. In the second period, you then have another ring around the first one. So now you have two. And then on the third period, you add a third, fourth, a fourth ring, and then fifth, and so on. So this trend kind of is intuitive. As you go down, you're adding rings, and so an additional ring, more electrons. Just by the nature of that, you can understand why it would be a bigger atom at the bottom of the periodic table. The trend of getting larger from right to left is a little more complicated. So if you're looking at the periodic table, we know that as you move from left to right, each atom is changing by the addition of one proton in the nucleus and an additional electron in its valence shell. So every time you go, from one atom in the same period, one to the right, we're adding on an additional proton and additional electron. So one thing we know about chemistry is that opposites attract. Electrons are negatively charged and protons are positively charged. So by nature, there is this force, this electrostatic force between the electrons on the outside of the orbitals and the core protons. And it's pulling the electrons in towards the middle. But what changes as you go from left to right is the amount of positive charge that is felt by the valence electrons. So there's two different types of electrons I want to talk about here. The first one being valence electrons, and the second one being shielding electrons. Shielding electrons are essentially core electrons. They're in the middle of the valence electrons, which are on the outside, and the proton in the middle. So what they kind of do is they act as a shield. They shield the outermost electrons from the positively charged nucleus. So they shield that force from being able to reach up into that valence shell. So as you continue, as you're going from left to right, you're adding more protons in the middle, which would then cause more of a force to be felt by the outside of those electrons, those outside valence electrons. And as you add, each proton you add, the force becomes greater. You're feeling a greater force from the positively charged nucleus on those outer electrons. And so what actually happens is you're also adding another valence electron on the outside, while the number of shielding electrons stays the same. So we have the same amount of electrons that are shielding that positive charge as you go from left to right, but what is increasing is the number of protons in the middle and the number of electrons on the outside. And because now on the right side of the periodic table, we have more electrons and more neutrons, but the same amount that are shielding, same way, or the same number all the way across the periodic table. The force felt on those electrons on the outside that is felt from the positively charged nucleus is greater. And so there's a greater attraction, which pulls in that cloud of electrons closer. So as you go from left to right, you see the atomic radius get smaller because now there's a greater force from the nucleus, that positively charged force felt by the outermost electrons. So that is why the smallest electrons are going to be, or not electrons, the smallest atoms are going to be in that right-hand corner, and the largest ones are going to be in the lower left part of the periodic table.